Hello everyone. Hope you are safe and sound. Let us begin today's session. Today we will learn scattering of light. First of all, let us understand what is scattering of light. It is spreading of light as a result of collision with particles of the medium. What is actually scattering of light? Atoms or molecules which are exposed to light absorbs light energy and re-emits light in different directions. So we can take example of white light. White light is scattered in all directions. So you will remember whenever atoms or molecules which are exposed to light, which means the atoms or particles collide with light, then as a result of this collision, there will be spreading of light in different directions. Again, what is scattering of light? It is spreading of light as a result of collision with particles of medium, which means whenever the light collides with the particles of the medium, and because of this collision there will be a spreading of light in different directions. This phenomenon is known as scattering of light. And this interplay of light with objects around us gives rise to several spectacular phenomena in nature. And they are the blue color of the sky, the color of water in deep sea, the reddening of the sun at sunrise and at the sunset are some of the wonderful phenomena we are familiar with. So now we will understand all these examples one by one. In Standard 9, we have learned about the scattering of light by colloidal particles. I want you to recall what we have learned. Let us recall it by taking an example. If we take a solution of water and milk, and this solution of water and milk, we will pass a light through this. So when we pass a beam of light to this solution of water and milk, what can we see actually? We will be able to observe the beam of light which enters into the solution of water and milk, and these type of solutions are called colloidal solutions, or else we can say it as colloid. So what are colloids? These are particles which are uniformly spread throughout the solution, but we are not able to see them with a naked eye. Why is it so? Because they have smaller size of particles, and that is why we are not able to see it with our naked eye. But when we pass a beam of light, then we are able to see the particles of colloid. And that is because of what? It is because of scattering of light. Again, recall what is scattering of light. When the light collides with the particles of the medium, then as a result of this collision, light will be spreaded and we can see the colloids clearly. So this effect is known as Tyndall effect. What is Tyndall effect? Scattering of a beam of light is called the Tyndall effect. And this effect is after the name of the scientist who discovered this effect. So that is why it is called Tyndall effect. Again, let us recall, when a beam of light is scattered, then the effect is known as Tyndall effect. So as we have taken example of solution of water and milk, when a light beam will spread the light into the solution, we can see the colloids clearly. And why are we not able to see it with our naked eye? Because the size of particles is relatively small than the other. And what is Tyndall effect? Scattering of beam of light is called the Tyndall effect. These particles, which are colloid particles, can be easily seen and they easily scatter a beam of visible light. So this is all about colloid and Tyndall effect, which we have already learned in standard 9. The Earth's atmosphere is a heterogeneous mixture of minute particles, and these particles include smoke, tiny water droplets, suspended particles of dust, and molecules of air. When a beam of light strikes such fine particles, the path of the beam becomes visible and the light reaches to us after being reflected by these particles. And this phenomenon is seen when a fine beam of sunlight enters a smoke filled room through a small hole. I'm sure you have observed it. Tyndall effect can also be observed when sunlight passes through a canopy of a dense forest. What is a canopy? It is the uppermost branches of the trees in a dense forest, or else you can say that the branches and the leaves that spread out at the top of group of trees and which forms a roof-like structure. So you can refer it as the uppermost branches and leaves, which covers all other branches and leaves, right? So the scattering of light through this canopy is also example of this Tyndall effect. The color of the scattered light depends on the size of the scattering particles. Very fine particles scatter mainly blue light, while the particles of larger size scatter of longer wavelengths. If the size of the scattering particles is large enough, then the scattered light may even appear white. We all have learned the spectrum, right? So if the particles are smaller, then they scatter smaller wavelength. If the particles are larger, then they scatter larger wavelengths. So this is all about Tyndall effect and scattering of light.